All right, good afternoon. Welcome back to Calculus 2. So today we are looking at the integral of the square root of x squared minus 9 all over x dx. Okay, it's an indefinite integral, so that'll be great. Now, again, we're talking about trigonometric substitutions. We've got a square root of a square, so even though I'm in the section, and that should be telling me, hey, here's the technique we're learning, but if we've got the square root of a square, I'm thinking there's got to be some kind of a triangle here. So I'm going to go ahead and draw my triangle. Okay. Now we have x in this case is this is a squared one. Again, we have a squared plus b squared equals c squared. Thank you, Pythagoras. So we are going to have that b squared is equal to c squared minus a squared, or c squared minus b squared is equal to a squared. Doesn't really much matter. But for this case, we're going to say, okay, the thing that's the hypotenuse in this case is going to be our x. And what I'm going to do is I'm going to say, let's make our 3 here, right? And then this last term here is going to be our x squared minus a squared, which will be 9. Okay, so we could label all the parts of our triangle this way. And in this case, we're going to have, okay, here's our thetas. Okay, so we have, let's see, we have secant of theta is equal to up hypotenuse over adjacent. So we're going to say x equals 3 secant theta. All right. So that's always good to use. Let's see here. We have a dx. We have to go ahead and remember what the derivative of secant is. We have 3 secant theta tangent theta, right? That's how that works. And then we'll be able to say what's going on next. All right. So as I'm looking at my little problem here, we have our x squared over x. That x squared over x, that's my opposite side. My x is my hypotenuse. X squared minus 9 over x, that's just going to be a sine x. Okay, so we go ahead and just say, well, that one, we could just go ahead and write that down and say sine of theta is equal to x squared minus 9 all over x. So let's go ahead and start substituting some things in. So we have our absolute value or our integral here. X squared minus 9 all over x, that is equal to sine theta. Okay. My dx, that's going to be 3 secant theta tangent of theta. Now, let me show you something because some of you will like to do it this way. Most of you will not, because the way that most YouTube presenters do it is like you memorize the substitution and you just go ahead and deal with it, and that's fine. But we can go back and say, okay, x was equal to 3 secant theta, so we can say x squared is equal to 9 secant squared theta, and then we can go into here and say, okay, there we have the square root of 9 secant squared theta, right, minus 9. Okay, back down here, minus 9. And what's going to happen is that we're going to factor out a 9, and then we have a square root of secant squared theta minus 1. Okay, and we have to go back. Remember, we have sine squared plus cosine squared is equal to 1. Let's divide everybody by cosine squared. Okay, because I'm looking for a tangent squared plus 1 is equal to secant squared. Secant squared must be equal to tangent. So we have secant squared minus 1 is equal to tangent squared. So when I get rid of all of this, we're going to have a tangent in here instead. The x, okay, is going to be 3 secant. So we can go ahead and replace them with let's see, we could replace this with a tangent. The x we're going to replace with the secant. So we'll have secant over tangent. I believe that's going to give me back a sine. Okay, so we can go ahead and double check all of that stuff. So we have tangent theta over secant theta, which is going to be sine theta over cosine theta times 1 over secant theta, which is going to be sine theta over cosine theta times cosine theta. So some stuff cancels and we end up with a sine. Oh, would you look at that? I ended up with a sine anyway. So you can do this in a number of different ways. Take which way is easiest for you. Take the way that you've practiced to do this. Like I said, most YouTube presenters go ahead and just tell you, well, when the function looks like this, when it looks like an x squared minus an a squared, substitute with x is equals to a secant theta. You'll just memorize those rules, and you can go ahead and apply them to where you're going to need to. We don't know that the function is going to be in the first quadrant. but usually we're going to say that theta is going to be between 0 and pi over 2. Okay, we're going to say that this has to be first quadrant stuff. Otherwise, it's going to get real messy with our absolute value signs in here. And I think a way that most of the books for calculus kind of give us a head start with this thing is like, by the way, all the integrals in this section are going to be first quadrant integrals, so that you can take our square roots of square things and not have to fuss with the absolute values of things. Okay, but in the last chapter, we talked about, well, what happens when we have powers of secants and tangents and we have sines and cosines? Turn everything into a sine and a cosine. So what I'm going to do here is say we have sine theta, we'll put the 3 out here, times 1 over cosine theta, times tangent theta. There's a d theta here. I forgot about that. So we end up with 3 integral of sine theta over cosine theta times tangent of theta, d theta, okay? Which is going to tell me that we have tangent times tangent. We have 3 tangent squared thetas, d theta. Boy, it's a good thing I did this off to the side, isn't it? So we have tangent squared plus 1 is equal to secant squared. So I know that tangent squared is equal to secant squared minus 1. So we have a power of tangent we have to go. So this is 3 integral secant squared theta. What is this? Minus 1 d theta. I believe that's what we're looking at for this. Okay. So if you remember the integral of secant squared, that's tangent. So we have 3 tangent of theta minus theta plus c, because now we have an indefinite integral. Don't forget your plus c's. Now, this is why I tell you to draw the triangle and why the substitution method is nice. If you memorize them, it's great, but here's a problem. You go back to figuring out what is the tangent of my theta, and that is opposite over adjacent. So we're going to say this is the square root of x squared. So we have 3. Okay, and now we're just going to type some stuff in. So we have x squared minus 9 all over 3, because we're going back up here to look at it. So we have opposite over adjacent. Now, what's theta? Now, theta is a little tricky because we know that x is equal to 3 secant theta. So we know that secant of theta is equal to x over 3. And then we don't usually deal with these in trigonometry because they're kind of a pain. But in this case, it's just one more step. But we're going to have that theta is equal to the inverse secant of x over 3. So we're going to say this is going to be 3 times the inverse secant of x over 3 plus c. Now these 3's on the top cancel here, so that'll be great. So we'll be able to see something like that. No, it's not 3 here, sorry. The extra 3 in here. It's just secant inverse of x over 3. That's where the 3 came from. So we have the square root of x squared minus 9 minus 3 secant inverse of x over 3 plus c. And that would be our answer for this kind of a problem. This is going to be pretty usual. If they give you an indefinite integral, you're going to have this mess to clean up. And it's just like, wow, this is a delightful looking integral, and I'm sure that secant inverse is delightful as well. And that's just the way it's going to sit. Okay, that's all we can do with that one because we have an indefinite integral. Okay, let's do another one that's not related to this one. It's a little bit easier. Okay, so we have an integral of 0 to 3 halves. Okay, we have an x squared, the square root of 9 minus x squared dx. Now again, you've got a square root of a square. That is screaming at you, use a triangle. Most of the time, I mean, it's going to work most of the time. May not work sometimes, but those are pretty few and far between. So in this case, we're going to say that we have a constant minus an x squared. We're going to make our hypotenuse equal to 3. 3 squared would be 9. And we're going to go ahead and pick this piece here to be our x. And then we have our 9 minus x squared sitting here. Okay, so that's where we are with this. And then we'll go ahead and say that's theta. Okay, so here we're going to be able to say something clever. We're going to say that sine of theta is equal to x over 3. That's a semicolon. X is equal to 3 sine theta. X squared. Why do I need x squared? Because x squared is sitting right there. Is equal to 9 sine squared theta. And of course, dx is equal to 3 cosine theta d theta. So now I'm getting ready to start substituting what I have to go deal with here, okay? So let's see what we have here. We have, what am I looking at? I'm looking at that. Okay. So, all right. So here's what I'm going to do. I'm going to do one more thing that's going to be clever. Like, why am I doing this? Is I multiplied by 1, 3 over 3. So we're going to be able to say we want 0 to 3 halves. We have a 3. I'm going to leave that 3 outside. We have an x squared times the square root of 9 minus x squared all over 3 dx. Now, why did I do that? Because I'm looking at my triangle and I'm thinking to myself, cosine theta is equal to the square root of 9 minus x squared all over 3, opposite, adjacent over hypotenuse. That's this whole piece. That's my cosine theta. So let's go ahead and substitute in. So we have 3 integral from 0 to 3 halves. What was my x squared? My x squared is going to be 9 sine squared theta. Okay. Yep, there we go. We have our x squared, my 9 minus x squared over 3. That's going to give me times cosine of theta. Okay. And then we have our dx, and our dx is going to be 3 cosine theta d theta. Okay. So we have 3 times 3 times 9, so we have an 81. Okay. And here we have the integral of sine squared theta, cosine squared theta, cosine times cosine. I'm going to do one more thing before I jump into doing this integral, is I'm going to go back up here and I'm going to say, hey, x is equal to sine theta. Okay, x is equal to sine theta. When x equals 0, we have 0 is equal to sine theta. Therefore, theta is equal to inverse sine of 0, which of course is 0. Okay, now we're going to have 3 halves. Okay, so here we have 3 halves. Where are we? Is equal to sine theta. Do I want to do it that way? No, we have x is equal to 3 sine theta. So we have 3 sine theta here. Okay. Divide both sides by 3. So we have 1/2 is equal to sine theta. Going back and remembering your unit circle. Of course you do, like it was yesterday. Who would ever forget that thing? We have sine inverse of 1/2, which of course is equal to pi over 6. Okay. So instead of these limits of integration, we're going to have 81 0 to pi over 6 of sine squared theta cosine squared theta. I'll tell you, this is probably one of my favorite problems in trigonometry because, or in calculus 2, because there's lots of different ways to do it. Now remember, we can't integrate sine squared directly. We can't integrate cosine squared directly. But I do remember that sine 2 theta is equal to 2 sine theta cosine theta. So what I'm going to do is I'm going to say this is 81 over 2 times 2. I've got 2 2's here. Okay, so we have pi over 6 here. So I have a 2 sine theta cosine theta. That's one of them, times 2 sine theta cosine theta. There's 2 of them. There's 2 2's, which now I have 2 2's on my numerator. That gives me the fact that we have 81 over 4. Okay, we have 81 over 4. Integral from 0 to pi over 6. Okay, and I've got sine of 2 theta squared, right? So we have sine of 2 theta squared. Let's go ahead and put the squared over here. You have a lot of different ways of doing this problem. This is the way that I'm going to like to do it. So remembering that cosine of 2 theta is equal to 1 minus 2 sine squared theta. Okay, let's go ahead and rearrange some stuff. So we're going to say that we have 2 sine squared theta is equal to 1 minus cosine of 2 thetas. I probably should have used a different letter rather than theta. Okay, because we have sine squared of 2 theta. That's going to be, so we have, let's go ahead. We have sine squared theta is equal to 1 minus cosine 2 theta all over 2. We have thetas. We have to go to 2. Here we have 2 thetas. I should have used W's or something. So we have sine squared of, we'll do that, 2w is equal to 1 minus cosine of 2w's all over 2. So we end up with 1 minus cosine of 4 theta all over 2. Okay, doesn't that look great? It sure does. So let's see here. We have all of that going. We have all of that going. All right. So let's see here. Yep. Okay. So we have 81 over 4, integral from 0 to pi over 6 of, we have 1 minus cosine of 4 theta. Oh, all over 2. We'll go ahead and push it out there. So we have 81 eighths. Okay, of course we do, because why not? Okay, so we have 81 eighths. Here we have 0 to pi over 6, 81 eighths. Here we have 1 minus cosine of 4 theta. Go ahead and integrate. So we have the theta here. So we have theta minus 1 over 4 sine of 4 theta, 81 eighths, as we're going from 0 to pi over 6. Okay, and that's pretty much what we're trying to deal with this here. All right, so that's what we got to go ahead and figure out. So as we plug these things in, we have 81 eighths. The zeros are going to be 0, so that'll be great. Pi over 6 minus 1/4, and now we have sine of 4 pi over 6. Okay, again, that's going to be 2 pi over 3. Again, I have no problem with you guys plugging this into a calculator. You don't have to remember what the unit circle is for the pi over 3 values. And oh, it's square root of 3 over 2. Like, yeah, you can do it that way, and that's fine. Okay, but you can use this into a calculator. Go ahead and get yourself an answer. And that's where we're going to go ahead and stop the video for this guy. Okay, so that's how this whole thing works. Again, there's a lot of different ways to do this. So I'm going to say thank you very much for watching the video. Practice one that makes it easy for you. If you like to go back to the X world all the time, you go right ahead and do that. It's not wrong. Sometimes it's a little tedious, but it's not wrong. Sometimes it's a little tedious changing to the limits of integration. Do it your way. Okay, so I say thank you very much for watching the video. I'll see you in the next one, and take care.